Hello everyone, welcome back to our YouTube channel. I am Kim and today I will be sharing a few tips with you on how to properly write up a lab report. But before I get into it, please note that our contact information is posted in the video description. Don't forget to subscribe to our channel and leave a like to our content. Also, you can head on over to our IG page and leave a follow. Okay, let's get into it. So, tips for writing up a physics lab report. So the tips I'm giving now can be used for any one of the labs, whether it be chemistry, biology, whichever, it can be used. So each lab have a format to follow where you have name, experiment number, date, apparatus or materials, related theory, results, graph, calculations, precautions, limitations, reflection, discussion, conclusion. So I'll be going through each of these briefly just for you to understand what is necessary when writing up the lab report. Okay, so for headings, you should ensure that all headings are underlined. I mean, it sounds simple, but it is necessary. So after completing the lab, ensure that all headings are underlined. And each of what I just mentioned, the format, those are headings. So those are what you should underline. Okay. So for apparatus, you should ensure that all the materials used in the lab is listed in the materials/apparatus section. So at no point in time should you mention that in a method you use, for example, a beaker, but it is not stated in the apparatus. Then they would wonder where was that beaker taken from, because it was not stated in the apparatus. So once you use it in the experiment, it should be stated, it should be listed in the materials or apparatus section. Theory and results. So a lot of person tend to write sometimes a full page or half a page for the related theory, and that's not necessarily what it is about. So the related theory is exactly to the point. So if you're given a topic, you write specifically on that topic, nothing else. So the related theory is not necessarily long, but it should not be too short, because if it is too short, there's a possibility that you've missed an important detail, right? So giving an example, say you're doing an experiment on forces of equilibrium, right? So we're focusing on forces in equilibrium. What are some things we can write in the related theory? So first, we can talk about center of gravity. So what is center of gravity? How do you find center of gravity of a regular shaped object or an irregular shaped object? Well, if the experiment is about a regular shaped object, you don't necessarily have to write about the irregularly shaped object. So we can talk about equilibrium, you can define equilibrium, you can mention moment. So that's just an example of what the related theory for the types of experiment forces in equilibrium would look like. So for the results, so ensure that when tabulating the results, the table title is above the table and is underlined. This is important. Ensure that there is consistency with the results in the table. So what this means is, so for example, you're tabulating your results and there are to some decimal points. If you're using two decimal places, you should ensure that all the results in that section, in that column, or in that row has exactly two decimal places. Not one, not three. Two, if you're using two decimal places. Okay. Graph calculations. So, a lot of person tends to lose marks on graphs, uh, simply because they don't label their axes properly. So when doing your graph, ensure that the axes are properly labeled. So if you're plotting a graph of, say, A versus B, that means that A goes on the y-axis and B goes on the x-axis, right? All right, another thing. A lot of persons have problems with finding scales. An easy way to find a scale is, say, in your table, say for example, you want to go on the y-axis by 2 centimeters. We can count up how much 2 centimeter boxes we can get. So for example, we want to go up to 10 centimeters, right? We can divide the largest number in the table by 10 to see how much we can go up by, because we know that the graph must take up at least 75% of the paper, right? So that's an easy way to find a scale. You divide the largest number in the table by the amount that you want to, by the amount of spacing you want on the graph. Alright, calculations. So when you're doing a calculations, ensure that you do not leave off the units. The units are important. So for example, if your gradients have a unit, when you calculate that, you ensure that the unit is there. Precautions, limitations, and reflections. So precautions are things you ensure to do before you start the experiment. So for example, you would ensure that your equipment are working, you would ensure that they're clean, and so forth. Limitations are things that occurred during experiments that you have no control over and may affect your results. So for example, we're doing a simple pendulum lab, right? We're supposed to count the number of oscillations. If, say for example, because we know that length affects the simple pendulum. So for example, you displace the pendulum at an angle, but while it is swinging, it is hitting on something or it starts to spin. Now that would be a limitation because you do not necessarily have control over the spinning of the simple pendulum, right? Okay, so reflections are things you have learned while doing the experiment that can be of help in your everyday lives. So now I may go into a little chemistry. So say for example, you have done an experiment titled saponification, right? So that's where you know you learn how to make soaps and so forth. As a reflection, you can state that while doing this experiment, you now know how to make your own soaps, which you know can be used for personal hygiene and so forth. So that would be a reflection. It's something that you've learned that you yourself can do to ensure that you're, to help in everyday life. So that's what the reflection is. Discussion and conclusion. Okay, so for discussion, when writing discussions, you can ask yourself some questions. So you can ask yourself, what did I do? Why did I do it? And how did I do it? So what is basically the experiment, right? Why you did it. That's basically your aim. That's why you did the experiment. To investigate, to determine, that's your why. How how is your procedure? So you would basically summarize your procedure. You would state what you have done in this experiment. Then you would state your results and errors that may have occurred in the experiment. That's basically a discussion. Conclusion now. Conclusion is normally a sentence or two stating whether or not the aim was achieved. So it's nothing long. You state whether um the aim was the experiment was successful and the aim was proven and so forth. That's basically your conclusion. So I really hope that these tips were of some help, and I really hope that you guys can use these to ace your lab writing up. That's it.